Imagine, if you will, that you were to gather together a collection of the most commonplace chemical elements, just the ordinary stuff. You'd need a fair bit of oxygen, about 45 kilograms of it, a good 12 kilograms of carbon, the very backbone of life as we know it, 7 kilograms of hydrogen, the universe's most abundant element, a couple of kilograms of nitrogen, a kilogram and a half of calcium for structure, and then a smattering of the rest. Phosphorus, potassium, a pinch of iron, a whisper of cobalt. Now imagine you place all of this precise chemical recipe for a human being, into a large, rather unassuming bag. Should you then carry this bag through a bustling public square, it's highly improbable that anyone would afford you a second glance. It would simply be a heavy bag, nothing more. And if you were to empty its contents onto the pavement, at most you might receive a stern word, perhaps a fine for littering what appears to be nothing more than inert chemical dust. There's no intrinsic value, no inherent sacredness in this dispersed collection of elements. But consider a different scenario. What if, instead of simply scattering these elements, you were to meticulously, atom by atom, begin to connect them in a rigidly predefined order, assembling them, molecule by molecule, into the grand, intricate architecture of a human being? At a certain critical juncture in this assembly process, a threshold would undeniably be crossed. Beyond this point, the nature of your endeavour fundamentally transforms. You would no longer be able to simply disassemble your creation at will. Because if you were to attempt to reduce this meticulously organised collection of atoms back into a mere bag of chemical dust, you would, with absolute certainty, be immediately restrained, condemned, and quite possibly incarcerated for many, many years. This thought experiment underscores a profound truth. At some undefinable point, this scattered collection of chemical trash inexplicably acquires a new, emergent property. A property that we, as a society, not only deem to be of immense, indeed almost sacred value, but one that we are prepared to protect with the utmost rigour. This inherent value isn't readily apparent in the isolated atoms themselves. It only manifests when they are arranged in a particular, complex and dynamic configuration. So, let's just pause and consider that for a moment. Your own being, the vessel that carries your consciousness through this unfolding tapestry of reality. If we were to meticulously quantify your physical composition, a fascinating yet perhaps somewhat humbling picture emerges. For an individual weighing approximately 150 pounds or around 70 kilograms, the intricate dance of elements that form you is largely comprised of the most common substances found throughout the cosmos. Roughly 45 kilograms of your total mass is pure oxygen, the very breath of life, intertwined within the water and organic molecules that define your structure. Another 12 kilograms are carbon, the fundamental backbone of all known organic chemistry, forming the intricate chains and rings that give rise to the complexity of biological existence. Where did that carbon come from? Well, it was forged in the heart of a dying star, a star that lived and died long before our sun was even a glimmer in the cosmic eye. Every atom of carbon in your body was once inside a star. Hydrogen accounts for approximately 7 kilograms, omnipresent in water and organic compounds, forged in the Big Bang itself, a fleeting partner in countless biochemical reactions. Nitrogen, essential for proteins and nucleic acids, contributes about 2 kilograms, while calcium, the architect of your skeletal framework and a vital signaling molecule, makes up a solid 1.5 kilograms. Phosphorus, a key component of DNA, RNA, and the energy transfer molecules that power your cells, adds around 700 grams, a hidden workhorse of cellular function. Beyond these major players, a myriad of other ingredients exist, present in smaller, yet equally crucial quantities. These include potassium, sulfur, sodium, chlorine, magnesium, iron, fluorine, zinc, copper, iodine, selenium, chromium, manganese, molybdenum, and trace elements like cobalt and vanadium. Each performs specialized, often enzymatic roles within the grand orchestra of your physiology. These elements, though diverse in their individual properties, collectively constitute the astounding complexity we recognize as a human being. When laid out in this precise, almost clinical manner, this list of chemical constituents might at first seem unremarkable, a collection of the most ordinary, ubiquitous chemical elements, nothing more, nothing less. It prompts a curious, almost disquieting thought. Is this truly all that we are? A carefully arranged, albeit highly sophisticated assortment of atoms? Forgive the bluntness, but in this reductionist view there appears to be quite literally not an atom of anything inherently mysterious or profoundly unique, just a configuration of elements from the periodic table, indistinguishable in their fundamental nature from the rocks beneath your feet or the distant stars. But pause. Is this truly the entire narrative? Or is there perhaps something more residing within you, within us all? Something that eludes the neat categorization of the periodic table? Something that, from a strictly scientific perspective, should not, or perhaps even cannot exist as a mere collection of fundamental building blocks? Could you possibly harbour a quality, an essence, beyond the atoms and subatomic particles that meticulously construct your physical form? This question, to many, might sound like the premise of a sensationalized documentary, veering into the realm of the implausible. Yet, our deepest insights into particle physics, the most granular understanding of the universe's building blocks, suggest a different, even stranger narrative. These insights tell us that if every single atom in your body were to be precisely replaced by another identical atom, you would, in essence, remain the same person. For you, subjectively, nothing would have changed. You would perceive no alteration in your sense of self, your I. If this notion seems fantastical or counterintuitive, it is in fact a process that is literally and constantly unfolding within your body every single moment of your existence. Back in 1954, based on groundbreaking experiments utilizing radioisotopes to track the movement of chemical elements both within and outside the human organism, nuclear physicist Paul C. Ebersold shared a truly astonishing conclusion. His research indicated that an astounding 98% of the atoms in the human body are replaced and renewed each year. Think about the profound implications of this. Throughout your lifetime, your physical body, in its entirety, undergoes multiple, complete renewals of its most fundamental building blocks. These atomic components are so remarkably interchangeable that, statistically speaking, there are atoms circulating within your body right now that, at some point in history, were integral parts of the brain of Isaac Newton, or perhaps a dinosaur, or a distant star. The atoms themselves are ceaselessly recycled, borrowed from the universe and returned to it. This constant radical physical transformation presents a deep philosophical conundrum. How can we possibly account for the unwavering, persistent sensation of being the same continuous individual throughout a lifetime, given that your entire physical foundation is in a state of perpetual flux? Your original body, the one you were born with, is, quite literally, undergoing a process of continuous dissolution and rebirth. It is, in a very real sense, experiencing a slow, molecular death as its components are exchanged. And yet, your inner self, your unique identity, your subjective experience of you, seems to endure, seemingly untouched by this relentless cellular and atomic turnover. For many religious traditions and spiritual belief systems, this paradox poses no significant challenge. They offer a remarkably straightforward explanation: the presence of a soul. As articulated by sources such as Wikipedia, the soul is often described as an immaterial essence, an underlying spiritual core that encompasses an individual's unique identity, personality, memories, and consciousness. It is by this definition an entity conceived to be capable of surviving the death and disintegration of the physical body, thus providing a continuous thread of selfhood independent of transient material forms. But does modern science simply dismiss such notions outright? What indeed can the scientific method, with its reliance on empirical evidence and verifiable observations, truly say about such profound and elusive questions? Recently, I immersed myself in the latest work by German theoretical physicist, philosopher of science, and expert in quantum gravity, Sabine Hossenfelder. Her book, which is not yet available in English under an official title, translates approximately to Existential Physics, a scientist's guide to life's biggest questions. The title itself, Existential Physics, serves as a potent hint, suggesting a daring foray by a physicist into the ancient enduring queries of philosophy. One might naturally agree that to hear such profound contemplations articulated from the perspective of a seasoned physicist, rather than solely from a pure philosopher or theologian, carries a unique weight and fascination. The scientific rigour, combined with a willingness to grapple with the unknown, creates a compelling intellectual space. And what can be said about her approach? She navigates these complex territories with a captivating blend of insight and audacity. Immediately upon its publication in mid-2022, the book garnered widespread acclaim, hailed by many, among other accolades, as a beacon of clarity and sound reasoning. I have, in the past, produced content exploring some of the ideas from another of her influential books, Lost in Math: How Beauty Leads Physics Astray. In that discussion, I touched upon the critical issue of how scientists who neglect the philosophy of science inadvertently undermine the very authority of science itself and, in doing so, lead research down unproductive dead-end paths. Existential physics can, in many respects, be understood as a natural continuation, an evolution of these earlier themes. Hossenfelder emerges as a formidable intellectual figure, coolly analytical, refreshingly audacious, and unapologetically direct, a true embodiment of German precision and intellectual honesty. She's not one to shy away from challenging conventional wisdom or exposing intellectual vulnerabilities. I wholeheartedly recommend her work, and tonight, as is our custom, we will embark upon a contemplative journey with Hossenfelder as our guide, delving into her profound insights. What she reveals is that a vast array of concepts that, on the surface, might appear unscientific or simply absurd, are, in fact, entirely compatible with contemporary scientific understanding. And perhaps more surprisingly, many of these seemingly outlandish ideas possess a surprising degree of underlying sense and coherence. But enough of books, you might be thinking, as if there were no other forms of intellectual engagement in the world. Let us instead turn our attention to one of the most compelling and essential warnings that Hossenfelder explicitly includes in Existential Physics. This disclaimer, one that will resonate deeply with regular listeners, is itself a piece of profound philosophy. She writes, with characteristic forthrightness, that her book might be a danger to the reader's mental health, and further, that one ought to give serious consideration to whether or not to even begin reading it, because, as she starkly puts it, some things cannot be unlearned. You might at this juncture be tempted to dismiss this as mere hyperbole, a clever rhetorical flourish designed to inject a sense of thrilling drama into the ostensibly dry realm of theoretical physics. A fair initial assessment, perhaps. And Hossenfelder herself, with her unwavering honesty, addresses this potential skepticism head-on. Listen, we all know I want this book to sell well, so why pretend that I don't? She acknowledges the commercial realities, but then she pivots to the core of her genuine concern. The main reason I make this warning is that I am genuinely worried that this publication might negatively affect the mental health of some readers. This is not a casual remark. She continues, recounting instances where individuals have reached out to her. From time to time, someone contacts me and writes that they stumbled upon one of my essays and now don't know how to live anymore. They seem genuinely distressed. Indeed, some scientific facts, when confronted without intellectual preparation or emotional resilience, can be profoundly difficult to internalize, to fully process and integrate into one's worldview. And, what complicates this further, she laments, is that there are no psychologists who could help here. I know this from my own experience. This speaks to the unique existential challenges posed by certain scientific revelations, challenges that conventional psychological frameworks may not be equipped to address. Let us now gently transition into what Hossenfelder introduces as Chapter 1, Thresholds of the Unknowable. She begins with a statement that immediately draws us into the cosmic sublime. The greatest mystery of the universe is supermassive black holes, a claim that, while bold, resonates with the profound awe these enigmatic objects inspire. No one, she asserts, truly comprehends their genesis, their origin point in the cosmic tapestry. To illustrate their monumental scale, she cites one of the largest black holes discovered to date, TON 618. The diameter of this colossal entity's event horizon, the point of no return beyond which nothing, not even light, can escape, is a staggering 1,000 times greater than the distance from the Earth to our Sun. To grasp this immensity, imagine our solar system. If we were to define its outer boundary by the orbit of Neptune, the most distant planet, then TON 618 would engulf our entire solar system not just once, but 17 times over. Its gravitational maw is truly incomprehensible. To further paint a picture of its terrifying grandeur, Hossenfelder offers a chilling thought experiment. An astronaut, intrepid enough to cross the event horizon of TON 618, would, astonishingly, remain alive for an additional 4 days. 4 full days of relentless, accelerating descent, a journey into the abyss, before finally reaching its central singularity, the point where its unimaginable mass, equivalent to 40 billion solar masses, is concentrated. This, she concedes, is undeniably impressive. Black holes are indeed objects of profound wonder and scientific fascination. But, she asks, where exactly does the fundamental enigma lie? The mystery, she explains, is this. The image we possess of TON 618, as it appears to us now, is a snapshot from over 10 billion years ago. This means we're observing it as it existed at the very dawn of our universe, in its infancy. And astronomers are utterly perplexed, unable to reconcile how, in such a comparatively brief cosmic timescale, this behemoth could have possibly grown to such a gargantuan size. According to the prevailing cosmological models of our day, supermassive black holes simply could not have had enough time to form and accumulate such immense mass within that early, constricted period of universal evolution. And yet, the perplexing observations continue to escalate. If the event horizon of TON 618, in comparison to Neptune's orbit, is already staggering, then consider the hypothetical, even more mind-boggling scale of a black hole known as Phoenix A. Its mass is estimated to be on the order of 100 billion solar masses, possibly even more. This transcends the very definition of a supermassive black hole. For such colossal entities, a new classification has been proposed: stupendous large black hole. These discoveries fundamentally challenge our assumptions. This raises a deeply unsettling yet intellectually invigorating question. How thoroughly, how accurately do we truly comprehend the universe's past? And how well do we genuinely understand the fundamental laws that governed it? Did the past truly unfold in the manner we currently envision? All available data consistently point to our universe being approximately 13.8 billion years old. And according to our current understanding, all the known laws of physics, in their familiar and consistent forms, are believed to have begun operating within the first fleeting moments immediately following the Big Bang, in less than a single second. Of course, the most parsimonious explanation, the one favoured by scientific caution, is that we simply do not yet fully comprehend the intricate mechanisms behind the formation of supermassive black holes. Our models are incomplete, our understanding still nascent. But Hossenfelder, ever the provocateur of thought, extends the inquiry further. Is it conceivable that, in the distant past, different laws of physics might have been in effect, laws that would have permitted these cosmic monsters to form with such rapidity? Or to pose an even more radical possibility, what if our current calculations, which yield an age of 13.8 billion years for the universe, are themselves based on incomplete or subtly flawed assumptions? What if the universe is, in actuality, unimaginably older, perhaps 100 trillion years old or even more? This is, admittedly, an exceedingly bold conjecture, a profound leap beyond our current empirical footing. But the honest scientific answer, Hossenfelder reminds us, is simply, no one knows. The notion of the fundamental laws of nature themselves undergoing change is something we have never, in the entirety of human observation, directly witnessed. Yet, the absence of observation does not, inherently, equate to an impossibility of occurrence. As Sabine Hossenfelder astutely observes, it is difficult to come up with mathematical laws that would look indistinguishable from the currently confirmed ones, but which would blow up the solar system tomorrow, meaning it is hard to conceive of an alternative set of laws that would appear to function identically to our current understanding today, only to dramatically diverge in the future. Not that anything speaks in favour of this, she clarifies, but nothing speaks against it either. This highlights a profound limitation. We cannot, by any means currently available to us, conduct experiments to verify the exact laws of physics that were operational in the deep past. It is quite simply an impossibility. We are compelled, therefore, to infer. We might, for example, confidently state that, according to the laws of physics known to us today, light from a particular distant galaxy travelled for 7 billion years to reach our telescopes. But how can we definitively ascertain that, say, 6 billion years ago, the speed of light wasn't, for instance, a mere 2 kilometers per hour? The stark answer is, we cannot. Physicists, in their rigorous pursuit of understanding, are forced to operate within the confines of what is currently known and verifiable. They take the laws that are established in the present, laws derived from the comparatively brief span of human existence and experimentation, and on that basis, extrapolate backwards into the past. This approach is entirely consistent with the scientific method, a pragmatic necessity. But does this strict adherence to scientific methodology truly imply that the laws of nature that govern our present, and upon which all our intricate calculations are based, were invariably the same in the past? Or that they will assuredly remain unchanged in the future? Hossenfelder's profound insight is to state unequivocally, no, it does not mean that. This, she argues, is nothing less than a question of belief. It touches upon a long-standing philosophical problem, elegantly articulated by David Hume centuries ago, known as the problem of induction. This is a concept I have in fact explored in a previous discussion. In essence, the problem of induction centres on the inherent impossibility of definitively predicting that nothing unforeseen or unpredictable will ever occur. We assume, based on past experience, that the sun will rise tomorrow. We assume that the laws of physics will continue to hold, but this assumption is, at its core, an act of faith, however empirically supported. There is no logical necessity, no absolute guarantee that the future will mirror the past. Hossenfelder recounts her own encounter with this foundational philosophical dilemma. When I, as a student, first learned about Hume's problem of induction, I was puzzled. I felt like someone had pulled the rug of reality out from under my feet, revealing a vast, disorienting truth beneath. The profound implications of this revelation, the realization that our entire edifice of scientific understanding rests upon an unproven, albeit highly successful assumption, can indeed be unsettling. It fundamentally alters one's initial reaction to news stories, such as the unexpected acceleration of Earth's rotation, with scientists scrambling for explanations. The thought that the world might be fundamentally inexplicable, that it could harbour an element of irreducible chaos, a chaotic disregard for our carefully constructed presumptions, is a deeply unsettling one. It feels, to many, simply unbearable. It's a curious phenomenon, often cited as a demonstration of humanity's inherent philosophical bent. If you navigate Wikipedia by continually clicking on the first link in each article, excluding parenthetical notes or links to disambiguation pages, you will, in approximately 97% of cases, eventually arrive at an article related to philosophy. This informal observation suggests that philosophy, in a profound sense, represents the ultimate frontier of our knowledge, the point where our most rigorous inquiries eventually lead us. And the scientific method, for all its unparalleled power, is no exception to this rule. Does the scientific method work? Yes, undeniably it works. Why it works, however, remains, in the final analysis, something we do not fully comprehend. And precisely because we do not fully grasp the underlying reasons for its efficacy, we cannot be absolutely certain that it will continue to function in the same predictable manner indefinitely. Sabine Hossenfelder reminds us that what we call science, the understanding of the limits of science, is always fluid. Consider Sir Isaac Newton, an intellectual titan widely regarded as the foundational figure of modern physics. In his era, his very name was almost synonymous with the word science, an embodiment of rational inquiry. Yet concurrently, Newton dedicated a significant portion of his illustrious career not to what we would recognise as physics, but to the arcane pursuit of alchemy. For 30 years of his life, he was deeply immersed in alchemical studies, his surviving notes on the subject encompassing over 1 million words. To put this into perspective, a typical novel of moderate length contains approximately 80,000 words. Newton amassed an enormous, and, by all accounts, arguably the finest alchemical library in the world. He spent 3 decades of his life in fervent pursuit of the mythical philosopher's stone, an elusive substance believed to prolong life and transmute base metals into gold. And crucially, he viewed this alchemical quest as being no different in its fundamental nature or scientific validity from his groundbreaking investigations into the laws of gravity. This historical fact eloquently demonstrates the shifting intellectual sands upon which our definitions of science are built. So, in succinct terms, what, according to Sabine Hossenfelder's contemporary understanding, constitutes science? She defines it thus: science is the search for useful descriptions of nature. The emphasis here lies on useful. By useful, she clarifies, she means descriptions that enable us to formulate accurate predictions for novel experiments, or that provide quantitative explanations for observations that have already been made. And there's a further crucial refinement to this definition. The simpler the explanation, the more useful it is. This elegantly encapsulates the principle of parsimony, or Occam's razor, a guiding tenet in scientific inquiry. Let us now gently drift into Chapter 2, Can the Universe Think? The very phrasing is designed to evoke a sense of quiet wonder and perhaps a touch of intellectual vertigo. According to the most recent astronomical observations, our universe is home to a staggering number of galaxies, conservatively estimated at no fewer than 200 billion. These galaxies are not uniformly distributed throughout the vastness of space. Instead, under the inexorable influence of gravity, they cluster together, forming intricate groupings, which, in turn, are interconnected by immense, filamentous strands of galaxies. These cosmic filaments can stretch for hundreds of millions of light-years, creating a vast interconnected network. This immense, if you will, cosmic web bears an astonishing, almost uncanny resemblance to the complex neural networks within a human brain. This striking similarity was not lost on researchers. In a study conducted in 2020, astrophysicist Franco Vazza and neurobiologist Alberto Filletti undertook a quantitative comparison. They meticulously calculated the number of structures of varying sizes contained within both the human brain and the cosmic web. The results, as they reported, revealed a striking resemblance, a quote that truly captures the imagination. This leads to a profoundly speculative, yet irresistibly intriguing question. Could the universe itself be a colossal thinking entity, with our own galaxy merely one minuscule neuron within its unimaginably vast cerebral architecture? Hossenfelder, with her characteristic blend of scientific rigour and open-minded speculation, acknowledges the immediate, seemingly insurmountable physical hurdles to such a notion. On one hand, she explains, this idea appears to fundamentally contradict the established laws of physics. The universe is immense, almost inconceivably vast. And due to the fundamental limitation of the speed of light, it would take hundreds of millions of years for a signal to traverse the distance between one galaxy and another. Given that the universe, since its inception, has existed for approximately 14 billion years, it is highly improbable that it could have engaged in much thought or information exchange in its lifetime. The universe, in its entirety, might have managed no more than 1,000 such exchanges between its closest neurons, a paltry sum compared to the billions of interactions our own brain processes in a mere 3 minutes. Moreover, the universe is not static. It is perpetually expanding, a process that continuously stretches these galactic connections, effectively diminishing its capacity to form and maintain rapid, intricate internal communications. This, then, represents the formidable challenge to the cosmic brain hypothesis from a conventional physical standpoint. But then, Hossenfelder, ever the explorer of theoretical frontiers, introduces a fascinating counter-argument, a speculative twist that dramatically reconfigures the possibilities. On the other hand, she writes, the universe might be permeated by a network of tiny wormholes, connecting distant regions of the universe. If these hypothetical wormholes, these shortcuts through space-time, were indeed to exist, then signals from far-flung corners of the cosmos could potentially be transmitted almost instantaneously, bypassing the otherwise prohibitive limitations imposed by the speed of light and vast distances. These connections, she explains, would be far too diminutive for us, or even for elementary particles, to physically traverse. Their diameter would be on the order of merely 10 to the minus 35th power meters, an incomprehensibly small scale. Yet, despite their minuteness, they would intimately intertwine the very geometry of the universe with its underlying structure, and, critically, there would be an astronomical number of such connections. Physicists Fatime Markopoulou and Lee Smolin, in their bold theoretical explorations, have estimated that in our universe there could be approximately 10 to the power of 360 such connections. To place this into astonishing perspective, the human brain, with all its intricate complexity, contains only about 10 to the power of 15 connections or synapses. The sheer magnitude of these hypothetical cosmic wormholes is almost beyond comprehension, and crucially, because these connections by their very nature would be non-local, meaning they inherently ignore distance, the ongoing expansion of the universe would become largely irrelevant to their communicative capacity. Hossenfelder, grounded in scientific caution, is quick to temper her speculation. I don't have particular reasons to believe that these non-local connections actually exist, or that if they did exist, they would truly allow the universe to think. Her integrity as a scientist shines through here. But, she adds, with a characteristic openness to possibility, I also cannot rule out such a possibility, however crazy it may sound. Her concluding thought on this mind-bending hypothesis is particularly profound. The idea that the universe is intelligent is compatible with everything we currently know. This statement is not an endorsement, but an invitation to consider the boundaries of our current knowledge and the vast unexplored territories of the possible. The immediate, often dismissive reaction to such a question, can the universe think? Does the universe possess consciousness? Is typically one of incredulity. What utter nonsense, one might think. No rational person asks such absurd questions. It's simply preposterous. Yet the critical point Hossenfelder highlights is that these are, in fact, profoundly important questions. And here's why. There exists a pervasive, deeply challenging phenomenon in philosophy of mind known as the explanatory gap. Allow me to illustrate its core dilemma. You possess with absolute certainty the experience of consciousness. You know beyond any shadow of a doubt that you have qualia, the subjective, phenomenal, qualitative experiences of feeling, perceiving, hearing, tasting, and touching. You have a palpable sense of your own self, an unmistakable experience of your individual I. Yes, indeed, this is one of my favourite topics, and I recognise that when the conversation turns to consciousness, some individuals may inwardly roll their eyes, thinking, oh, not this again. And it is true that a significant number of individuals, particularly within certain scientific disciplines, tend to deny the existence of a problem of consciousness, asserting that it is merely an emergent property of complex neural networks, fully explainable by physical processes. However, these individuals, though vocal, remain in the minority among philosophers, and many scientists engage directly with these questions. For consciousness has been, and continues to be, one of the greatest enduring mysteries of science. To underscore its profound significance, consider a special issue of Science magazine published in 2005. This issue unveiled a list of 125 open questions in science, the grand challenges that stood before the scientific community. Can you guess which question secured the coveted first place? No, it wasn't a question about consciousness. The top spot was claimed by What is the Universe Made Of? An absolutely deserved victor, given that, in the grand scheme of things, no one definitively knows what constitutes 96% of the matter and energy in our world, the elusive dark matter and dark energy. But the second place question? Yes, indeed, It was, what is the biological basis of consciousness? This placement clearly signifies its status as a monumental unresolved puzzle. So, you undeniably know that you possess consciousness, this rich, internal sensory experience. For you, the presence of your own self, your unique subjective world, is self-evident. The profound difficulty, however, lies in the fact that verifying the existence of consciousness in another human being is, by any known scientific method, utterly impossible. We have no objective instrument, no definitive biomarker, no foolproof test that can conclusively confirm the presence of subjective experience in another entity. This problem is not new. Over 400 years ago, the brilliant philosopher, physicist, and mathematician Gottfried Leibniz proposed a thought experiment that remains remarkably relevant today. He articulated it thus: it must be confessed that perception, and what depends upon it, is inexplicable by mechanical causes, that is, by figures and motions. And if we suppose there were a machine so constructed as to think, feel, and have perception, we could conceive of it as enlarged, while retaining the same proportions, so that we might enter into it as into a mill. And supposing this, we should find nothing but pieces working upon one another, but never anything by which to explain a perception. Leibniz was intimately familiar with mechanisms. He invented numerous devices, including a mechanical calculator that remained in use for 300 years until the advent of electronic computers. He believed that human logic could be accurately modelled and simulated by computational machines. Yet, even with his profound understanding of mechanics and logic, he saw no conceivable way for a machine to generate subjective perceptions, the raw, qualitative experiences of consciousness. How can I be this? This, precisely, is the explanatory gap. We lack a coherent logical bridge from the purely physical system to the emergence of consciousness within it. The Soviet physicist Anatoly Dneprov, in 1961, proposed the first conceptual outline of an experiment now famously known as the Chinese brain thought experiment. Its most widely recognized and elaborated form was described by the American philosopher of mind Ned Block in 1978. The essence of the experiment is as follows. Imagine the entire Chinese nation, then 500 million people, gathered together in an enormous field. The task assigned to each individual Chinese person is to simulate the function of a single neuron within a human brain. And crucially, they are to communicate with other neurons, other people, using telephones, in a strictly analogous manner to how neurons interact. In this system, each person would possess a telephone and a specific list of numbers of other individuals they are supposed to connect with. The entire nation of China would thus collectively emulate the complex interconnected operations of a single human brain. Depending on when a particular Chinese person's phone rang, representing an incoming signal to a neuron, they would then, in turn, dial a number from their list, simulating the firing of that neuron. According to a significant number of philosophers, such a colossal system, comprised of 500 million individuals, would, astonishingly, possess a unified, emergent consciousness. Just as an individual neuron in your brain does not, on its own, experience self-awareness, so too would no single Chinese person in this experiment feel conscious in that unified way. However, the entire system, as a coherent, interacting whole, would experience a singular, unified subjective awareness. For instance, the Chinese brain might experience pain, even though no individual Chinese person within the system would feel that pain. One might immediately object, dismissing this thought experiment by arguing that such a system would be prohibitively slow and cumbersome, rendering it utterly dysfunctional, thus preventing any form of consciousness from emerging. However, Ned Block himself, the author of the experiment, writes that it is completely unclear why the temporal scale of the system should matter at all. The profound implication here is that the speed at which a system processes information may not be a defining characteristic for the existence of consciousness, merely for its speed of operation. Do you grasp the profound philosophical schizophrenia this thought experiment reveals? Ned Block, in fact, originally devised this experiment precisely to demonstrate what he considered to be its inherent absurdity. Yet many prominent thinkers disagreed with his conclusion. Daniel Dennett, one of the most celebrated philosophers of our time, in his influential book Consciousness Explained, argued that the Chinese brain could create any mental state that an ordinary human brain creates. And ultimately, is it truly more intuitively obvious that a quivering mass of grey biological substance is a more fitting carrier of subjective experience than an enormous collective of individuals acting in a coordinated, unified endeavour? In matters concerning the exploration of the fundamental nature of the universe, it is highly perilous to rely on our intuitive judgments. Our intuition, throughout the entire sweep of human history, has proven to be a monstrously unreliable guide. Let us now shift our contemplative gaze into Chapter 3. Is a human just a bag of atoms? Imagine, if you will, tracing the universe's grand, unfolding narrative forward through time from the very instant of the Big Bang. In this cosmic epic, everything has evolved sequentially. Each event has been predicated upon a preceding event. Every consequence has had its own discernible cause. One might envision the entire universe as a colossal billiard table. A ball cannot spontaneously begin to move, nor can it abruptly halt without some preceding cause. Therefore, every single movement of every single ball on this colossal table could, in principle, be calculated and predicted, both backward into the past and forward into the future, with absolute precision, given perfect information. This concept, the bedrock upon which our understanding of the physical world is built, is known as the principle of causal closure of the physical world. It asserts that every physical event has a purely physical cause. The world we inhabit is not a chaotic free-for-all. It is a universe where the laws of physics are, for the most part, deterministic. This means that if you know the precise state of the universe at any given moment, then, in principle, you could perfectly predict its future state and accurately deduce its past state. The current laws of nature, as presently understood, are largely deterministic, with one crucial exception: the element of randomness inherent in quantum mechanics. This implies that the future is, to a significant extent, predetermined, save for the genuinely random quantum events upon which we, as macroscopic beings, have no discernible influence. So, returning to our initial question, what are you? A collection of 45 kilograms of oxygen, 12 kilograms of carbon, and so forth. You are, in this scientific framework, a meticulously assembled collection of ordinary chemical elements. You are, in essence, a complex billiard ball, subject to the very same fundamental physical laws that govern everything else in the universe. And in the finest traditions of reductionism, the philosophical approach that seeks to understand complex systems by breaking them down into their simplest components, the logic unfolds. If we were to meticulously dissect your body down to its constituent atoms, if we were to ascertain the precise properties of each individual atom and understand how they interact with all other atoms, then, theoretically, we would be able to explain absolutely everything about how your brain and body function. We would, in this grand vision, be able to predict in advance every decision you make. And if you're now feeling a familiar weariness, thinking, "Oh, for heaven's sake, not again with these discussions about the absence of human free will," I would gently ask you not to rush to judgment. For Sabine Hossenfelder, a specialist in elementary particle physics, offers a nuanced perspective. She writes, "As a specialist in elementary particle physics, I must inform you that the available data indicate that the whole is the sum of its parts, no more and no less." This is a powerful, concise statement of reductionism. Countless experiments over millennia, she continues, have confirmed that objects are composed of smaller objects, and if you know what the smaller objects do, you can say what the larger objects do. There is no known exception to this rule. Yet Hossenfelder, with her characteristic intellectual honesty, then adds a crucial qualifier. "Nevertheless, I am not an advocate of reductionism. Our knowledge of the laws of nature is limited. Much remains to be understood, and reductionism may fail in some subtle aspects. On one hand, if one truly grapples with the implications, the absence of free will seems almost self-evident. To posit otherwise is to suggest that you are a chaotic billiard ball, somehow capable of defying the predictable forces that govern all other matter, and our perception that our decisions are free might simply be an illusion, a consequence of our inability to know the outcome of our deliberations before we have completed them. As Ludwig Wittgenstein mused, the freedom of the will consists in the fact that future actions cannot be known now, but what truly amazes Hossenfelder is our profound, almost visceral resistance to the idea that we are merely biological marionettes. We are all deeply averse to the notion that we might be nothing more than unwitting puppets, devoid of genuine agency. But if, in the grand narrative of evolution, nothing occurs without a purpose, then what possible biological meaning or evolutionary utility could there be in our profound belief that we possess free will and our ferocious defense of this idea? Hossenfelder notes, with a touch of perplexity, "I have not heard a single convincing opinion on this matter. The question lingers. Why do we so desperately cling to this illusion, if indeed it is one? Our entire civilization, our intricate legal systems, our courts of justice, all of it is fundamentally predicated upon the unspoken assumption that human beings possess free will." Robert Sapolsky, the renowned neurobiologist, controversially argues that we ought to abolish punishment for criminals, given the deterministic nature of our biology. "I say good luck to him," Hossenfelder might respond, expressing a realistic skepticism. It seems highly improbable that human society will ever permit such a radical shift. And, she adds with a piercing observation, she wonders how many individuals who intellectually espouse Sapolsky's views would maintain their conviction if a crime were committed directly against them or their loved ones. "I am not saying that they are wrong," she clarifies. "I am saying that what people think they believe and what they actually believe are very often two very different things." Hossenfelder observes a recurring pattern. "I found that many people reflexively reject the possibility that human consciousness arises from the interaction of many particles in their brain. They seem to adhere to the idea that there must be something else in consciousness. And," she adds, with a precise understanding of human psychology, "and although people with a scientific mindset do not call it a soul, that is exactly what they mean. They are looking for something mysterious, inexplicable, and amazing, something that would make their existence special. Consciousness, in this view, seems utterly unlike any physical process we currently understand. Its subjective, felt quality seems fundamentally distinct from the objective, measurable properties of matter. It sounds as though our consciousness might be something non-physical, but can there be anything truly non-physical in a universe governed by physical laws? The straightforward answer is, once again, we do not know. Because physicalism, the philosophical stance that everything that exists is fundamentally physical, is precisely that, a philosophical position, not an empirically verified scientific fact. However, if consciousness were indeed to possess some non-physical nature, then, as Sabine Hossenfelder astutely observes, in that case, it could not influence anything. Why? Because according to the fundamental principle of the causal closure of the physical world, every cause of a physical event is solely and exclusively a physical event and nothing more. This is a long-standing, deeply challenging problem in philosophy of mind known as the problem of mental causation. If the mind is non-physical, how can it possibly exert any influence over the physical body? A non-physical entity simply could not interact with the physical realm. Can physics then resolve this deep paradox? Lord Kelvin, the eminent physicist, famously wrote, "The power to direct the motions of matter, daily exhibited in the miracle of human free will, and in generations of plants grown from one seed, is infinitely different from any possible result of the accidental collision of atoms." While Kelvin was certainly mistaken about plants, his intuition about free will perhaps touches upon a deeper, more intractable mystery. The simplest resolution is to assert that consciousness simply does not influence anything. A second, more complex option is the multiverse interpretation of quantum mechanics. A third and perhaps most radical option is to consider that causality itself might have an exception. From the perspective of modern physics, there is one extraordinary phenomenon that quite plausibly, truly is capable of tearing apart the very fabric of causal connections, the inside of a black hole. it may turn out that space itself is merely one state, and a very rare state of the universe. Most theories of unified physics suggest that the predominant, most natural state of the universe is non-spatial. The existence of space-time, as we experience it, is considered a remarkably atypical condition. The fundamental building blocks of space, throughout the vast majority of the universe, may typically exist in a chaotic, non-spatial state. But in rare instances they can coalesce to form a simple, ordered lattice. This is what we refer to as the Big Bang. However, the underlying chaos never truly vanishes. The universe we perceive as unfolding in space, George Musser suggests, may be merely a surface where we float like small boats, while monstrosities churn in the depths. At any moment, this latent chaos can erupt. The very building blocks that constitute our causally coherent space can lose their ordered arrangement and revert to a non-spatial structure. And this is precisely what occurs inside black holes. Space, quite literally, disintegrates, and events within black holes lose their distinct position and their progression through time. This implies that black holes might be regions where all cause and effect relationships are shattered. This beautifully illustrates a deeper principle. Individual atoms of hydrogen and oxygen are not wet. Yet, when they combine in the specific ratio of H2O, they form water, a substance with entirely new, emergent properties. In precisely the same way, space, in this view, is formed from elements that are themselves non-spatial. This phenomenon is called emergence. And everything we currently understand about the universe suggests that only a weak form of emergence exists. This means that while we may not be able to directly deduce the laws of animal behavior from the laws of elementary particles, it doesn't imply that such a deduction is fundamentally impossible. It simply means our current understanding is insufficient. However, scientists and philosophers are engaged in a debate regarding strong emergence. Strong emergence posits the existence of fundamentally novel phenomena that cannot, in principle, be predicted or explained, regardless of how much we understand about the underlying components. It would fundamentally challenge reductionism, asserting that the whole is not equal to the sum of its parts. The profound challenge here is that we have yet to discover a single instance in the world that unequivocally demonstrates the property of strong emergence. Yet many thinkers advance the hypothesis that consciousness is, quite possibly, the first known candidate for strong emergence. So if you want to believe in free will that is genuinely governed by laws of nature, independent of the laws of elementary particles, then the possibility that the derivation of macrophysics leads to a singularity seems most reasonable. It's improbable, but it's compatible with everything we currently know. There is a certain beauty in this thought, that just as black holes are embodiments of chaos, so too perhaps are human beings. No one truly knows what transpires within their deepest interiors. Let us now, with a gentle transition, move into Chapter 4. Does the universe have a creator? I believe you would likely have long since surmised Sabine Hossenfelder's particular religious inclination. She is an agnostic. In simple terms, an agnostic is someone who believes that because we are inherently incapable of fully comprehending the surrounding world, we can therefore never confidently assert anything definitive regarding the existence or non-existence of God. There simply isn't enough information accessible to us. Yet concurrently, Hossenfelder has also candidly stated that it would be remarkably simple to convince her of God's existence. God would merely need to descend from the heavens and perform some undeniable miracles. And upon hearing this, I found myself pondering, why precisely would this constitute proof? Because to recall a fundamental principle, Arthur C. Clarke's third law states, any sufficiently advanced technology is indistinguishable from magic. How then could we definitively know that we were witnessing the hand of God, rather than, say, the elaborate deception of an incredibly advanced alien civilization, or that we hadn't simply lost our minds? In short, one could conjure a million alternative explanations. This is precisely the core of agnosticism. Human capacity for knowledge possesses inherent insurmountable limitations. Sometimes, Hossenfelder reflects, the only scientific answer we can give is, we don't know. Science, as a useful way of describing the world, does not exclude the existence of a creator, but it also does not require its existence. If we set aside the specific dogmas of any particular religion and simply contemplate the concept of God in its most general terms, as an omnipotent, omniscient, benevolent creator, it seems to me that if we were to somehow definitively discover that such a God truly existed, it is highly improbable that we would find this revelation comforting. On the contrary, we would instantly grasp that we were in fact living in an utterly unpredictable, profoundly chaotic world, a world where there exists an unknown agent, an entity possessing absolute free will and infinite power. Compared to this, even the most colossal black holes would seem like simple, predictable entities. It would be entirely unclear why such a God would necessarily conform to human notions of goodness or justice. Are we consistently good and just? There is a film that explores this very theme, the unsettling implications of suddenly discovering the existence of a being who is, in essence, godlike, and who also happens to resemble us. It is a being capable of annihilating the entire human race, and if there is even the slightest probability that this being is our enemy, then by extension, it is our enemy, and it must be destroyed. Yes, I am speaking of Batman vs. Superman, Dawn of Justice. In this film, Bruce Wayne, Batman, adamantly insists that Superman must be eliminated precisely because he is too powerful and critically possesses free will. He is therefore inherently unpredictable. Even though Superman is, at that moment, unequivocally not humanity's enemy, Bruce Wayne's chilling pronouncement, "but he could be," speaks directly to the core of human nature. Through the voice of Bruce Wayne, at that pivotal moment, speaks the entirety of human experience. And science, in its dispassionate analysis, suggests that if the universe does possess a creator, that creator could very well be as imperfect, as flawed, as we ourselves are. Theoretical physics even suggests that if we were to take something not particularly massive, say a standard computer chair, and concentrate all the energy contained within its atoms within a minuscule region of space, we would, in all likelihood, instantly become gods. Alan Guth, Andre Linde, and many other eminent physicists have demonstrated that creating a new universe requires a finite, quantifiable amount of energy. According to the most optimistic estimations, the creation of an entirely new universe would require approximately 10 kilograms of pure energy. Sabine Hossenfelder acknowledges that this is extremely far from our current technologies. But theory, she asserts, says there are no fundamental limitations to this. It's possible that one day we will be able to create a new universe in a laboratory. Such a nascent universe would then grow and separate from our own. From the perspective of the newborn universe, she describes, it would briefly resemble a tiny black hole. It would disappear in a fraction of a second. And with a touch of cosmic melancholy, she adds, "We would never know if there were inhabitants there and what happened to them." The Russian-American physicist Andre Linde, one of the primary architects of the theory of the inflationary universe, once said, "If I wanted to send a message to the inhabitants of a universe I created, I would record it in the local laws of physics." He further elaborates, "And to transmit a long and meaningful message, I would have to make these laws sufficiently complex. For example, I would have to ensure that the masses of the electron, proton, and neutron were in non-trivial ratios, the deciphering of which would become a serious task for future physicists. Therefore, it is not beyond the realm of possibility that we, without even realizing it, are currently engaged in a profound act of decipherment, attempting to unravel a hidden message from the superintelligent, albeit by no means divine, creators of our world. Now, let us bring our contemplative journey to a close with a final, resonant image. In the expansive public square opposite the British National Library stands a monumental bronze sculpture. Poised on a tall plinth, this striking work by Edoardo Paolozzi is simply titled Newton, and it directly references the iconic engraving by William Blake. Considering Blake's profound antipathy towards Isaac Newton and his critique of the reductionist scientific approach, one might wonder, is this not the most incongruous monument to erect in such a place? I, however, propose a different interpretation. I believe that the bronze statue of Newton in this context stands as a quiet yet powerful reminder to all who visit. It whispers that while the human intellect, with its rigorous scientific methods, is an astonishingly potent instrument for unraveling the mysteries of reality, no true or complete scientific understanding of the universe will ever be possible if we remain willfully blind to the inherent limitations of that very instrument. The deeper symbolism suggests that the world, in its bewildering grandeur, is ultimately something more than merely the sum of our current scientific descriptions of it. And we, in our own unfathomable complexity, are also something more than just the aggregate sum of the atoms that constitute our physical form. We are the conscious observers, the curious questioners, forever suspended between the known and the unknowable, drawn by an irresistible urge to comprehend the universe and our place within its unfolding narrative. Thank you for sharing this contemplative journey.